Welcome back to ControlX Engineering. I'm Akhil, and today we are continuing our deep dive into industrial safety with TwinSAFE. This is part 3 of my 3-part Getting Started with TwinSAFE series. In part 1, we explored the TwinSAFE hardware ecosystem, including safety logic and I/O terminals. In part 2, we explored the TwinSAFE software and learned how to create a high-integrity SIL3 safety project from scratch. We tested and validated the logic in simulation mode, entirely within TwinCAT's powerful development environment, to prove that our logic works perfectly in the virtual environment without even connecting any physical hardware or wiring. Before we dive into part 3, I strongly encourage you to watch parts 1 and 2. Everything we cover here builds directly on the concepts and foundations established in those earlier episodes. Now it's time to put all of that together. Today in part 3, we take the final step. We are going to commission the TwinSAFE hardware terminals in TwinCAT. I'll show you how to set up the FSoE addresses for I/O terminals and confirm the safety checksums. We'll see how to set up the Alias devices for the I/O terminals, download the safety logic to the EL6910 controller, and I'll show you how to link your standard PLC variables to read the I/O status from the TwinSAFE terminals. I will be hooking up physical push buttons and relays as per the logic from part 2 and perform a real-world safety validation. By the end of this video, you won't just have a program on a screen, you'll have a fully functional SIL3 certified safety system running right in front of you. So grab your cup of coffee and let's get started. The complete documentation for working with TwinSAFE can be found at Beckhoff Information System website. Before moving further, I would like to thank Beckhoff Canada for generously providing us the EL6910 safety logic terminal featured in this tutorial. Let's review my hardware setup for this tutorial. I will be using my CX5140 IPC. We will add a route to this IPC from my programming laptop, which I will use to create the PLC and safety logic. The first terminal in the configuration will be the EL2809, which is a 16-channel digital output terminal. We will link a standard PLC variable to control the green tower light connected to one of its output channels. Next, I've installed the EL6910 TwinSAFE logic terminal. This is where the safety logic will be programmed and saved. If you recall our application from part 2 of the series, we had a dual-channel e-stop, 2 push buttons, and a dual-channel safety door interlock switch. These required SIF input channels. Therefore, we required 2 EL1904 safe input terminals, each with 4 channels. And for our safety outputs, we have the 4-channel EL2904 terminal. Finally, we will terminate with the EL9011 end cover for protecting the electrical contacts on the last terminal. In part 1 of this series, we reviewed the TwinSAFE hardware and learned how to set the safe addresses on the terminals using the 10-position dip switch block on the back of the terminals. Devices like the EL6910 and EL2904 have single dip switch blocks with 10 switches labeled from 1 to 10, which gives us addresses from 1 to 1023 as shown. Each FSoE address has to be unique and can only be used once within a network. Also note that 0 is not a valid FSoE address. Last time I showed you how to manually set up the FSoE addresses for these terminals using their Alias devices. This time I'll show you how to scan the FSoE addresses automatically from the terminals via their aliases. If you don't know what aliases are, then I encourage you to check out the previous 2 parts of this series. To make it interesting, I have assigned random FSoE addresses to the 3 I/O terminals, and I will show you how to scan them in the hands-on portion of this tutorial. Back in the safety node of the Solution Explorer, we already learned how to set up the EL6910 as the target system, which serves as an alias device for the EL6910 logic terminal. Since we did this virtually in part 2, none of this information was available. However, once we have the hardware connected, it will display the information from the EL6910 terminal. This field shows the serial number, which is unique for every logic terminal. It is also printed on the side of the EL6910 along with the date code. This field will display the project's CRC code. After the safety logic has been downloaded to the terminal, the CRC of the program stored on the target system is displayed here. Currently it's displaying 0 because this is a brand new terminal out of the box. Checking these 2 boxes adds the mapping of the serial number as well as the project CRC, which will now become accessible under the EL6910 terminal in the I/O tree. The serial number will be available as an unsigned double integer and can be linked to a standard variable, which makes it accessible to the PLC. The safe address is also retrieved from the logic terminal and displayed here both numerically as well as graphically, showing the position of the 10 switches on the dip switch block. The safe addresses of the TwinSAFE I/O terminals are configured in their respective aliases. Double-click on the alias for the terminal you want to configure. On the linking tab, we can see the physical dip switch address here. For this terminal, the address is set to 32. Click on this green arrow button to assign the hardware address as the FSoE address. This step needs to be repeated for all the safety aliases. However, this step can be taken care of automatically if the aliases are imported from the I/O devices directly. Next, move over to the Connections tab. The info data contains useful diagnostics information that can be made available in the process image of the logic terminal. This allows the information to be mapped to the PLC, if required, by linking with standard PLC variables. I highly recommend checking these two boxes to map the inputs and outputs for all the TwinSAFE I/O terminals. This is particularly useful if you want to monitor the safety channels to display that information on your HMI. As an example, imagine a machine has multiple e-stops and safety switches. Mapping the inputs allows you to show the operator which device triggered the safety stop. Similarly, mapping the output applies to the EL2904 terminal to monitor the status of the output channels. Keep in mind that these mappings are for monitoring purposes only and cannot be used to change state of the safety channels from the PLC. I will show you how to link the standard PLC variables to monitor the state of the safety channels next. The Safety Parameters tab is available on both TwinSAFE input and output terminals. Here I'm showing the tabs for EL2904 and EL1904 terminals. These are advanced settings and have to be set correctly to match the required performance level for the application. I will not be covering this part in today's tutorial. Let me know in the comments below if you would like to see me cover the safety parameters in a future tutorial. The EL6910 has 8 LEDs as shown here, 4 for diagnostics and 4 for states. The diagnostic LEDs were covered in part 1 of the tutorial series. 3 of the 4 diagnostic LEDs are red and only diagnostics 1 LED is green, which indicates that the operating voltage and internal tests are good. When the terminal is first powered, the diagnostic 1 LED should always be lit green. The other 4 green LEDs indicate the state of the logic terminal. A brand new EL6910 out of the box has no program loaded on it. Only state 4 LED will be illuminated when first powered up. Other 3 state LEDs are off. When a project has been downloaded to the EL6910 terminal, all 4 state LEDs will be illuminated at power up. Let's review the various toolbar options available for TwinSAFE. We have used this button previously when developing the safety logic. This option verifies the safety logic on the project level, meaning that only software properties are verified, no hardware connection. This option verifies the complete safety project on both the project as well as hardware level, meaning that hardware connections and availability are also validated. This button allows downloading of the safety project to the target system. During the download process, the user credentials will have to be entered like username, password, and serial number of the target system. We will review this process in more detail shortly. Logic can only be downloaded to the safety terminal after it has passed the validation check. This button allows us to delete the safety logic from the target system. User credentials will have to be entered similar to when downloading to the target. The Customize button is used for advanced applications like switching off TwinSAFE groups and setting off safe substitute values for the group outputs, etc. For this tutorial, we will not worry about this function. The multi-download button function allows us to download all safety-related configurations and logic to the selected TwinSAFE target devices in one operation. This includes the compiled safety logic, safety parameters, and configuration data for all TwinSAFE modules associated with that logic terminal. It is essentially a batch deployment tool for safety projects. While a standard download button sends the program logic to the target device, the Download Safe Addresses button specifically targets the FSoE slave terminals such as EL1904 or EL2904. Use this button if you have changed the safety address using a dip switch and only want to update the FSoE addresses without downloading the full safety project. The Glasses button is my favorite. It allows us to view the online data for the target system. In this view, active connections and ports of the use function blocks are shown highlighted green, as we saw earlier. This button only works when both the safety application on the target system and the TwinCAT XAR runtime are running. The debug function allows us to test our program safety logic virtually inside the development environment without downloading it to the target system first. I demonstrated this feature in part 2, so make sure to watch that. The remaining buttons are all related to this debug function. Once you enter the debug mode, hitting this button starts the simulation. This button allows us to pause the simulation. This button allows us to run one cycle only. When the simulation is running, we can hit the pause button and then use this button to execute one cycle. Similar to the one cycle function, this button allows even more granular logic execution by activating one function block at a time. Pressing this button again executes the next function block and so on. The function blocks are executed in order of their execution number. If you look at the function blocks, they have a number on the top right corner, which shows their execution order. If you're enjoying this tutorial, then please make sure to hit that like button and share it with your friends. Also take a moment to subscribe to the channel if you haven't already, so you don't miss out on future videos. We got plenty more automation tutorials, product reviews, and engineering content coming your way. And hey, smash that hype button to help the channel grow and reach more learners around the world. Alright, now let's dive into TwinCAT and bring our safety logic to life. I'm in TwinCAT 3 and I have the project open from last time. This time I have my physical hardware connected, so my working laptop is connected to the CX5140 IPC from Beckhoff. The first thing we're going to do is connect to the IPC. So we can go here, so let's do that. So let's pretend we don't have this thing set up for us. We would go into search. Now if you know the IP address of your IPC, you can type that in. In my case, it's 170.16.3.250, and it finds it right away. But let's try another way. We'll do search, and this time we'll do a broadcast search. Now it will give you an option of all the available adapters. If you know which adapter your IPC is connected to, you can just leave that one unchecked. And so in my case, it's connected to this one, so I'll leave everything else unchecked. It's doing a search, and it finds my IPC. Now for me, it's already connected. For you, if it's not, you would highlight it and click Add Route. Then we can close and select the IPC and hit OK. So now here you will see your IPC listed instead of local. So now we are connected to the IPC. Let's head over to the I/O section. We don't need this for now. Now this is my I/O. I'm going to collapse everything. Now the one big difference is if I look over my I/O, I have the EL2809 output channel, but in part 2 of this tutorial we worked with EL2008, so obviously we'll have to change that. But we have to do one more configuration setup before that. Let's head over to the device, top level, and we have to modify the adapter. Right now it's set for this option. All my I/Os are on the PCI slot, so we'll select PCI. So if I do a search, these two are the RJ45 connectors. My I/O terminals are not connected to a remote coupler, they're connected directly to the IPC, so we have to select this. Now here it shows the selected PCI slot. Once that's done, we do a reload. And actually before that, I have to change this. So I'm going to go ahead and delete this card. And in its place, we are going to put the EL2809. Now remember, we have to do an insert to add an item on top of this. So from here, I can do a search, 2809, and that's my card. So that's added. Let's do a reload now. Now we can say no to activate free run. And now let's head back to the top level and let's check out our topology. So this is what the offline, let me just zoom into this. This is the offline topology, and this is my 2809, and then my logic terminal. This is the A, B, and 2904. So we can do a show topology. And once you see this, that means your online and offline topologies, they're matching. So far so good. We can close this. Now we are done with the I/O for now, so we are going to collapse this. And next thing we have to do is update the target system. So let's go back to the target system, hit the plus button, and select our EL6910. And now you will see it has populated all this information. We have the software version, serial number, and the project CRC. So currently it's 0 because there is no project downloaded onto the terminal. Most important part here is the dip switch address. I have set it to 1, which we can see here, and it shows that numerically here. Now because we scan this in, the FSoE address is automatically taken from the hardware address. If for whatever reason this number is different, or if you have changed the hardware address after this step, we can click this up arrow and that will copy this to here. Similarly, we have to update the FSoE address for all the other terminals. So I'm going to do a save and close this part. You can close this. Expand the alias devices and update the aliases for FSoE for all the 3 aliases. I'll start with module A, So my dip switch is set to 32, but if you recall from the previous tutorial, we had set this manually to 4. So all we need to do here is take over, and it copies 32 here. Okay, all 3 addresses are updated. We can do a save all and close everything. Now we can do a safety validation. It says verification process succeeded. Let's just take a look at our safety project. In order to link all the I/O statuses to the PLC, we have to map the inputs and outputs. So let's do that. I'll go from top to bottom, go to the connections page and map inputs and outputs. Similarly for the other 2 cards. Now we can save all. And we do a build. Now we head over to the I/O section, expand the EL6910. We see this new item added here, which contains all our mappings. So this is module A. If you expand it, you have the 4 channels. So before we activate the project, we can create all the standard variables in the PLC and we can start linking them to here. So I'll go ahead and do that now. Let's head over to the PLC side and we'll create a new GVL. My variables are created. So let's just do a quick recap. I have my e-stop on channels 1 and 2 of A, my reset push buttons on channel 3, and the unlock request buttons on channel 4. My door switch contacts are connected on channels 1 and 2 of the second safety input card. My safety output relays are connected on the channels 1 and 2. The lock command for the safety switch is on channel 3, and the door safety OK relay is on channel 4. So I'll go ahead and link these to the channels. But before that, we have to do a build. Now if you look at the PLC safety instance, which is right here, if you expand this, our inputs contain all these variables. These are the only 2 outputs. So let's go ahead to the EL6910 in the I/O terminal and start linking them. So you would link these just like any other terminal. You can right click, do change link. This is channel 1 on A. Or we can double click and use this part, channel 2, channel 3, so those inputs are connected to the I/O. I also have these 2 aliases which need to be linked. So the 2 PLCs, safety OK, e-stop safety OK and door safety OK, which are these 2. So if you look at our PLC instance and PLC task inputs, they're all connected. Now we can head over to our safety logic, do a safety validation check again, and now we can proceed with the download. So you can either do a complete safety download or you can do a multi-download. We select this, next. The username is administrator. Password is TwinSAFE. Enter the password one more time. Process succeeded. Now we can go ahead and activate the project. Restart in run mode, yes. Now this icon will turn green and my IPC is in run mode. Okay, I'm ready to test the logic. In order to make this more intuitive, I'm going to share a visualization I created, which maps all the TwinSAFE inputs and outputs, so we can see it more visually. So to do that, I am going to collapse the instance. Here's my visualization. Let's reorganize the screen. Here's my visualization, and I have mapped all the EL1904A inputs. So first two channels are the E-stop, which is a dual contact, normally open and normally closed E-stop. I have the reset push button, unlock push button, and on the other EL1904, I have the two channels of the door switch. On the safety output terminal, I have the first two channels, power relays 1 and 2. This bit locks the guard door interlock, and this is another safety output that indicates the door safety OK. This one is linked to the TwinSAFE run alias, which will put TwinSAFE into run mode. So let's go ahead and log in. Okay, TwinSAFE starts in stop mode. I'm going to toggle the run bit. Now my TwinSAFE group is in run state. Let's test the push buttons. So I have my reset push button and my unlock request push button. My guard door is actually open, so let's close the guard door. You can see these two inputs indicate my guard door is closed. My E-stop is actually pushed in. That's why when I hit the reset button, there is no reset. So in order to do the safety OK, let's pull the E-stop out. So my NO is open, NC is closed. This condition is satisfied. So when there's a reset rising edge on the reset push button, it should reset this function block. And once this output is true, another toggle on the restart should turn on this output. So let's do the first restart. So my safety OK bit is true. My two safety relays have closed. My guard door is still unlocked. So let's hit the restart one more time. So door lock switch is set. My interlock is locked. And door safety command output is also true. This output can be used on the robot controllers, motion controllers, STOs, and that kind of things. So let's say the operator wants to go inside the robot cell to do some tooling change or maintenance or whatever. So he pushes the unlock push button. That drops the door safety OK bit, unlocks the door. Now he could go ahead and open the door and do his stuff. He just walked in. He's doing his work inside the robot cell safely. There's no motion. After it's done, he comes out, he closes the door. And door safety OK bit is still false because he hasn't reset it. If he wants, he can open the door again. It's still unlocked. Comes back out. The door is locked. He hits the reset push button. That locks the door. The machine is fully operational. All motion STO has been restored. Motion is functional. Conveyors are moving. The robots are functional. Now let's say there is an emergency situation. So the operator hits the E-stop. That drops our safety relays out. So the machine is fully disabled. All functions have been turned off, including the door switch. And of course, all this information is being relayed to the PLC by means of these two bits. So now the PLC can do other non-safety related tasks, maybe indicate some stack light, tower light. And speaking of tower light, remember that green tower light we connected to EL2809. That can actually be tied to this bit. I'm not going to show in this tutorial. We already know how to link EL2809 or other standard digital output terminals. So I've demonstrated full safety compliant SIL3 rated safety logic using the EL6910 and the input and output terminals. The last thing I want to demonstrate before we wrap this episode up is the document generation. So head over to the TwinSAFE menu and you'll see an option for generate documentation. So let's try that. So it populates today's date. You can modify the editor name, and we can hit generate. I will save it on my desktop. It's called Safety Tutorial. Let's take a look. So I generated this 29-page documentation. The project CRC is shown here, name of the solution, name of the project, and then we can add our programmer and customer information here. It shows the target system with the serial number and the CRCs, as well as the safe address. Overview of all the alias devices. Information about each alias device. All the standard alias device table. So these are the ones we link to the PLC, and it shows going from and to. All the local variables and the PLC are also added, shown here. And here I think it shows all the individual function blocks for the network. All the variable assignments and usages. And that's it. Hope you enjoyed this tutorial. See you in the next one. Thanks for watching. If you found this video helpful, then please like and share. If there's a particular topic you want to see me cover, then please drop your suggestions in the comments. And be sure to hit the subscribe button so you don't miss out on future content.